Hey everyone, and welcome to The Explainer. I am so incredibly thrilled you're here today because we are going to be exploring the absolute backbone of daily DevOps tasks. We're talking about the exact technology that makes managing thousands of servers worldwide possible completely without ever leaving your desk. That's right, we are talking about SSH. This explainer is basically going to hand you the keys to the kingdom. So whether you're a total beginner in DevOps or you just kind of want to solidify your mental model of how secure remote access actually works, you are definitely in the right place. Let's get into it. Okay, let's dive right into this. Here is the mental map for our explainer today, so you know exactly what we're going to cover. First, the remote access problem. Second, what is secure shell? Third, the magic of key pairs. Fourth, making the connection. Fifth, important SSH configuration files. And lastly, SSH in daily DevOps.
All right, kicking things off with Section 1, the remote access problem.
So, picture this. In the modern cloud environment, gone are the days where you could just physically plug a monitor and a keyboard into a machine in a freezing cold server room. Today, your servers are mostly floating virtual machines hosted halfway across the world, right? Which brings us to a massive, fundamental question that every single DevOps engineer faces on a daily basis. How do you manage a server you literally cannot physically touch? You absolutely need a secure bridge to that EC2 instance sitting in Virginia, and it has to be a bridge that hackers can't easily cross. Which brings us to the industry standard solution in Section 2. What is secure shell? Let's demystify the jargon here. SSH, or secure shell, is a network protocol. Simply put, it gives users a totally secure, heavily encrypted way to access and manage a computer over an unsecured network. And by unsecured network, I basically mean the public internet. Out of the box, almost every Linux server out there has an SSH process just quietly running in the background, waiting for a valid connection. When you fire up an SSH client on your local machine, you are creating a secure encrypted tunnel right into that remote server. It is, without a doubt, your primary tool for logging in safely. Now, you might be wondering, okay, but why not just use a simple username and password to log in? Well, technically you can, but there's a very good reason major cloud providers actually disable password authentication by default. Passwords can be guessed, they can be brute forced, or they can be leaked in data breaches. SSH key pairs, on the other hand, are unbelievably secure. They use RSA encryption to create a highly complex mathematical link. So when you use an SSH key pair, you aren't just typing in a password, you are presenting this complex cryptographic certificate that mathematically proves exactly who you are. It's just fundamentally more secure than any password could ever hope to be. And that leads us nicely into Section 3, the magic of key pairs. Now, what's really interesting about this slide is the analogy we can use to understand how this authentication actually functions in the real world. Think of your cloud provider's firewall as a super strict security guard standing at the front door of your server. The key pair, that's your unforgeable certificate of identity. When you try to connect, the server doesn't even bother asking for a password. Instead, it looks at the public key it already has on file and basically says, "Prove to me you have the matching private key." It's a literal mathematical lock-in key. The security guard checks your certificate, sees that it perfectly matches the lock, and just waves you right through the door. And because of this exact setup, there is a golden rule in DevOps, perfectly captured by this quote from our sources. Always preserve your key pair. It is the way of logging into your instances. Guys, your private key is the ultimate master key. It's usually a file ending in .pem or .ppk, and you have to fiercely guard it. If someone else gets their hands on your private key file, they can completely bypass that security guard and just walk right into your server. No questions asked. So never share it, never ever commit it to a public code repository, and just always keep it locked down securely. Let's move on to the actual application of this in Section 4, making the connection. So we know what SSH is, and we know why we use key pairs. Let's look at the practical side, how we actually create and use these keys day to day. Here is the life cycle of an SSH key. Step 1, you generate the keys. You can do this right in your terminal using a super simple command like ssh-keygen. Boom, that creates two files, a public key and a private key. Step 2, you store that private key locally on your laptop. Keep it safe. Step 3, you place the public key on the remote server you want to connect to. Fun fact, when you launch a brand new EC2 instance in AWS, AWS actually takes your public key and bakes it right into the server for you during setup. You keep the private key, the server keeps the public key, and you are officially ready to connect. So what does the actual terminal command look like to make this happen? Well, it looks exactly like this. Let's break this down really quick. You type SSH and then -I. That -I stands for identity file, which is you telling the client, hey, use this specific private key to prove who I am. Then you provide the path to your downloaded key, something like downloaded_key.pem. After that, it's just the username at the IP address. If you're in AWS, the default username for Amazon Linux is ec2-user, or it's Ubuntu if you're spinning up Ubuntu servers. You just hit enter, the keys do their mathematical handshake, and just like that, you're inside the server. But wait, before you actually hit enter to connect, there is one absolutely crucial step for your private key file. If you try to run that SSH command and your private key file is globally readable by anyone else on your laptop, the SSH client will actually completely deny the connection. It'll throw an error saying the permissions are way too open. To fix this, you just run the command chmod 400 on your private key file. This ensures the file is read-only and strictly only for the owner. It prevents accidental modifications and guarantees that even if someone else happens to be logged into your local machine, they absolutely cannot access your master key. Let's move to Section 5 and see how this builds under the hood. Important SSH configuration files. If you truly want to master SSH, you really need to know what's happening behind the scenes. So here is your ultimate cheat sheet for the hidden.ssh folder. First up, ID_RSA. That is your default private key, the one you fiercely guard, like we talked about. Then there's ID_RSA.pub. That's your default public key, the one you can just freely share with any servers you want to access. Then we have the known_hosts file. Basically, the first time you connect to a new server, SSH saves its unique fingerprint here to protect you against man-in-the-middle attacks down the line. Pretty neat, right? And finally, the authorized_keys file. Now, this one lives on the remote server. Think of it as a VIP list for the club. It contains all the public keys that are officially allowed to log into that specific machine. If your public key is in that file, you are getting in. And speaking of the remote server, here is a massive configuration setting you need to know about. Inside the server's sshd_config file, there's a setting called password authentication. Major cloud providers like AWS and Azure intentionally modify this file to set it to no by default. This explicitly tells the server to completely 100% ignore any password login attempts and only accept SSH key pairs. It is a fundamental security baseline that guarantees maximum safety for your cloud infrastructure. Finally, let's wrap things up with Section 6, SSH in Daily DevOps. We've covered a lot of the mechanics, right? So let's zoom out to the big picture and see how this protocol actually fits into a daily DevOps workflow. Because let me tell you, SSH is so much more than just a way to log into an EC2 VM to check a random log file. It is literally the absolute foundation for DevOps automation. When you interact with GitHub to push or clone your code securely without typing a password every time, you're using SSH. When you use a config management tool like Ansible to automatically install software across hundreds of servers all at once, Ansible's doing that by establishing passwordless SSH connections to every single one of those machines. You can even use SSH to set up secure port forwarding tunnels, allowing you to securely access a private backend database right from your local laptop. It is seriously everywhere. And that brings us to the end of our journey today. We've seen just how incredibly powerful and fundamental SSH really is. But before we wrap up, I want to leave you with this somewhat provocative question to think about. If your private key is the ultimate master key to your entire cloud infrastructure, what is your strategy for actually keeping it safe? Because as you move forward in your DevOps career, securely managing these secrets becomes just as critical, if not more so, than writing the code itself, something to chew on. Thank you so much for joining me on this explainer. I hope